We live in a world our ancestors would barely recognize. Around the globe, the impact of human ingenuity is now everywhere. We've pushed back the limits of our planet at speeds, depths, and heights that would have left our forebears breathless. Driving all these achievements is humankind's extraordinary gift for invention. Through genius and inspiration, we've created exceptional solutions to complex problems, from the everyday to the spectacular. Some good and some not so good. This series celebrates the million ways our great inventions have transformed our world.
That's one small step for man, one giant leap for mankind.
It's so simple, so perfectly circular, yet without it, our world would grind to a halt. From the carts that built civilizations to the vehicles that define modern life. One invention rolls through every chapter of human history, but this revolutionary idea didn't appear overnight. It emerged from thousands of years of struggle, innovation, and sheer human determination. The wheel, an invention so fundamental we barely notice it's there, yet it changed everything.
Today we take wheels for granted. They're everywhere. On our cars, our bicycles, our suitcases, even the cursor on your computer screen moves because of technology inspired by the wheel. But rewind 6,000 years, and the world looked very different. A world without wheels was a world where everything was harder, slower, more exhausting. Imagine trying to move a massive stone block without wheels. You'd need dozens of people, rolling it on logs, dragging it with ropes. It would take days, maybe weeks, to move something just a few kilometers. The wheel didn't just make life easier, it made civilization possible. The story begins in ancient Mesopotamia, in what is now Iraq, around 3,500 BC. This is where we find the earliest evidence of the wheel, not on a chariot or a cart, but in pottery workshops. Potter's wheel. The potter's wheel was a game changer. Before its invention, shaping clay by hand was slow, painstaking work. Each pot was unique, but also irregular. Then someone had a brilliant idea. What if you could spin the clay while you shaped it? Suddenly, pots became symmetrical, production sped up, and pottery became an art form. But the potter's wheel was just the beginning. Because once humans understood the principle of rotation, once they grasped that a circular object could spin around a fixed point, the possibilities were endless. The next leap was transportation. Around 3200 BC, someone in Mesopotamia looked at a potter's wheel and thought, what if we could use this to move things? And so, the wheel was adapted for use on carts and chariots. The first wheels were solid, carved from single pieces of wood. Heavy, cumbersome, but absolutely revolutionary. Think about it. For the first time in human history, you could load goods onto a cart and have animals pull it. Trade routes expanded. Cities grew. Armies became more mobile and more deadly. The wheel wasn't just a tool. It was a catalyst for change. But here's the fascinating part. The wheel didn't spread everywhere immediately. Some of the greatest ancient civilizations, like the Incas and the Aztecs in South America, never developed the wheel for transportation. They had mountainous terrain, dense jungles, and no large domesticated animals to pull carts. So they relied on human labor and ingenuity in other ways. It's a reminder that even the greatest inventions need the right conditions to flourish. Back in Mesopotamia, the wheel kept evolving. Those early solid wooden wheels were heavy and slow. So around 2000 BC, someone had another breakthrough, the spoked wheel. By removing material from the center and adding spokes, wheels became lighter and faster. Chariots could now race across battlefields. Merchants could travel greater distances in less time. The Bronze Age was in full swing, and the wheel was at the heart of it all. The spoked wheel was a marvel of engineering. Each spoke had to be perfectly angled, perfectly balanced. Too few spokes and the wheel would collapse under weight. Too many and it would be too heavy. Ancient craftsmen had to understand tension, compression, and weight distribution, even if they didn't have the mathematical language to describe it. From Mesopotamia, the wheel spread to Egypt, to Europe, to Asia. Each culture adapted it, improved it, made it their own. In China, wheels appeared on chariots around 1200 BC. In Europe, the Celts developed iron-rimmed wheels that were stronger and more durable. The wheel became universal, a symbol of progress and innovation. But the wheel's journey didn't stop with transportation. Oh no. Humans are far too creative for that. We started using wheels in ways the original inventors never imagined. Water wheels, for instance. By the 1st century BC, the Romans were using water wheels to grind grain. A river's flow would turn a large wheel, which turned a series of gears, which powered millstones. Suddenly, producing flour became faster and more efficient. One water wheel could do the work of dozens of people. The Romans were masters of engineering, and they understood leverage, gears, and mechanical advantage. Water wheels spread across the Roman Empire, and later, throughout medieval Europe. Mills became the beating heart of medieval villages. Every community needed one to grind grain, saw wood, or power early industrial processes. And then there's the windmill. In the 7th century AD, in what is now Iran, someone looked at a water wheel and thought, what if we could use wind instead? The first windmills appeared in Persia, and they transformed agriculture. By the Middle Ages, windmills dotted the European landscape, grinding grain, pumping water, and driving early machinery. The wheel was no longer just about transportation. It was about harnessing energy, multiplying human effort, and building the foundations of industry. But we're getting ahead of ourselves. Let's go back to the road. By the Middle Ages, wheeled carts and wagons were common across Europe and Asia. But there was a problem. Roads were terrible, muddy, rutted, barely maintained. Wheels would sink into the muck, axles would break, and journeys were slow and dangerous. Transporting goods overland was expensive and risky. So for centuries, water transport, rivers and seas, remained the preferred method for moving heavy goods. It wasn't until the 18th century, with the dawn of the Industrial Revolution, that roads began to improve. Engineers like John Macadam in Scotland developed new road-building techniques. Macadam's method, known as macadamization, involved layers of crushed stone compacted to create a smooth, durable surface. Suddenly, wheeled vehicles could travel faster and more reliably. The wheel and the road were finally working in harmony, and then came the railways. In the early 19th century, steam locomotives changed everything. Wheels on rails meant heavy loads could be moved with unprecedented efficiency. The railway boom transformed economies, connected cities, and shrank the world. But here's the thing. Railway wheels are different from road wheels. They have a flange, a lip on the inside edge, that keeps them on the track. This simple feature prevents derailment and allows trains to navigate curves at high speeds. The engineering behind railway wheels is extraordinary. They need to handle enormous weight and friction. They're precisely shaped, with a slight taper, so that when a train goes around a curve, the wheels automatically adjust, with the outer wheel traveling a slightly longer distance than the inner wheel. It's a self-steering mechanism, elegant and effective. But let's not forget the humble bicycle. In the 19th century, inventors were experimenting with two-wheeled vehicles. Early designs like the penny farthing had a giant front wheel and a tiny rear wheel. They were fast but dangerous. Riders sat high above the ground, and falls were common and often serious. Then, in the 1880s, the safety bicycle appeared. Equal-sized wheels, a chain drive, and pneumatic tires. This design was revolutionary. Bicycles became affordable, practical, and popular. They gave people, especially women, unprecedented freedom and mobility. Cycling clubs sprang up, roads improved, and the bicycle became a symbol of modernity and independence. Pneumatic tires, invented by John Boyd Dunlop in 1888, were a game-changer. Instead of solid rubber, tires filled with air provided a smoother ride and better grip. The principle was simple but brilliant. Air cushions the impact, absorbing shocks and vibrations. Dunlop's invention didn't just improve bicycles, it paved the way for the automobile. And here we are, the automobile, the invention that truly brought the wheel into the modern age. The late 19th and early 20th centuries saw a flurry of innovation. Engineers like Carl Benz and Henry Ford took the wheel and combined it with the internal combustion engine. The result? Personal, powered transportation. Early cars were unreliable, expensive, and rare, but Henry Ford's assembly line changed that. By mass-producing the Model T, Ford made cars affordable for ordinary people. Suddenly, wheels were everywhere. Roads expanded. Suburbs grew. The car became a symbol of freedom, status, and the modern lifestyle. But car wheels are more than just circles of rubber and metal. They're feats of engineering. Modern wheels are lightweight but strong, designed to handle high speeds, sharp turns, and heavy loads. They're made from aluminum alloys or steel, precision engineered to balance weight, strength, and cost. And then there are the tires. Modern tires are marvels of material science. They're made from synthetic rubber, reinforced with steel belts and fabric layers. Tread patterns are designed to channel water away, providing grip in wet conditions. Tire pressure is carefully calibrated to optimize performance, fuel efficiency, and safety. The relationship between the wheel and the road is a constant dance of physics. Friction provides grip, allowing cars to accelerate, turn, and stop. But too much friction means wasted energy and wear. Engineers constantly refine tire compounds and tread designs to find the perfect balance. And it's not just cars. Wheels are everywhere in modern life. Trains, planes, trucks, buses, motorcycles, skateboards, shopping carts, office chairs. Every day, billions of wheels turn, carrying people and goods, supporting industries, and keeping the world moving. But the wheel story doesn't end with transportation. In the 20th century, wheels took on entirely new roles. Gears, for instance, are just wheels with teeth. They're used in clocks, engines, factories, and machinery of all kinds. Gears allow us to change speed, direction, and torque. They're the hidden heroes of mechanical engineering. And then there's the flywheel, a heavy wheel that stores rotational energy. Flywheels smooth out the power delivery in engines, store energy in power grids, and even help stabilize satellites in space. The principle is ancient, but the applications are cutting edge. Let's talk about bearings. Wheels need to spin smoothly around an axle, and that requires minimizing friction. Ball bearings and roller bearings use small spheres or cylinders to reduce contact between surfaces. This simple idea makes everything from bicycles to jet engines possible. Without bearings, wheels would grind to a halt. The invention of the ball bearing in the 18th century was a quiet revolution. Suddenly, wheels could spin faster, last longer, and carry heavier loads. Bearings are everywhere, hidden inside machinery, making the modern world function smoothly and efficiently. But what about the future? Where is the wheel headed next? Some might say it's being replaced. Maglev trains, for instance, float above the track using magnetic levitation. No wheels, no friction, just smooth, silent speed. Hyperloop concepts propose shooting passenger pods through vacuum tubes at incredible velocities. Again, no wheels in sight. Yet even in these futuristic systems, the principle of the wheel lives on. Rotation, circular motion, the efficient transfer of energy. These concepts are timeless. The wheel may change form, but its essence remains. And let's not forget the digital revolution. The scroll wheel on a computer mouse is a direct descendant of the ancient wheel. It translates rotational motion into digital commands, allowing us to navigate virtual worlds. The wheel has gone from moving stones to moving information. In robotics, wheels are essential. Mars rovers roll across alien landscapes on 6 independently controlled wheels, each one designed to handle rocky, uneven terrain. These wheels are their own kind of marvel, with flexible spokes and carefully designed treads to maximize traction on Martian soil. Even in space, wheels play a role. Reaction wheels help spacecraft adjust their orientation. By spinning a wheel in one direction, the spacecraft turns in the opposite direction, thanks to Newton's third law. It's a simple, elegant solution to a complex problem, and it's all based on the wheel. But back on Earth, the wheel faces new challenges. As cities grow and traffic congestion worsens, we're rethinking transportation. Electric scooters, e-bikes, and shared mobility platforms are changing how we move. Yet they all rely on wheels. The wheel adapts, but it endures. And what about sustainability? Modern tires are made from petroleum-based products, and they wear down, releasing microplastics into the environment. Researchers are developing eco-friendly alternatives. Tires made from natural rubber, recycled materials, or even bioengineered compounds. The wheel must evolve to meet the demands of a changing planet. In manufacturing, 3D printing is beginning to revolutionize how wheels are made. Instead of casting or machining, wheels can be printed layer by layer, allowing for complex designs and lightweight structures that were previously impossible. The wheel is being reimagined yet again. Throughout history, the wheel has been a constant companion on humanity's journey, from ancient Mesopotamia to the modern metropolis. It has rolled alongside us, adapting, improving, and enabling progress. It is a symbol of human ingenuity, a testament to our ability to solve problems and shape the world around us. The wheel is more than an invention. It is a mindset. It represents the idea that we can take the natural world and bend it to our will, not through brute force, but through cleverness and creativity. The wheel teaches us that the simplest ideas can have the most profound impacts. So next time you see a wheel, take a moment to appreciate it. Think about the countless generations who refined it, improved it, and found new ways to use it. Think about the potters in ancient Mesopotamia, the chariot builders of the Bronze Age, the medieval millers, the railway engineers, the bicycle inventors, the automotive pioneers. All of them contributed to this one elegant, circular idea. The wheel hasn't just transformed our world. It has helped define what it means to be human, to innovate, to adapt, to keep moving forward. The wheel rolls on, and so do we. Because in the end, the wheel is more than just a circle. It is a revolution. That is all for today. Hope you enjoyed the video, and don't forget to like and subscribe. Until then, I'll see you next time.